Something unprecedented landed on Windows Update on June 9th, 2026. And depending on which side of it you landed on, it was either the most important security release Microsoft has ever shipped, or the latest in a string of updates that broke things they weren't supposed to touch. Microsoft's June 2026. Patch Tuesday is now officially the largest in the company's history. More than 200 security vulnerabilities patched in a single update cycle, a number that doesn't just break the previous record but obliterates it. At least 6 of those vulnerabilities were 0 days, meaning attackers had already found and exploited them before the patches existed. Over 30 were rated critical, including at least 28 remote code execution flaws that could let a malicious actor run arbitrary code on any unpatched Windows system. The scale of this release is genuinely without precedent in the history of Patch Tuesday. The reason for that scale is where the story gets genuinely interesting and where the user frustration gets genuinely complicated. Microsoft has been deploying AI tools internally to review its own source code for security vulnerabilities, and those tools are extraordinarily good at their job, far better and far faster than traditional manual code audits. An internal Microsoft AI system referred to as M- has been analyzing vast quantities of Windows and related source code, and in combination with other AI-powered security tools, including automated fuzzing engines and security copilots, continuous telemetry analysis, it's been surfacing vulnerabilities at a rate that human reviewers simply couldn't match. The result is that Microsoft is finding and fixing more bugs faster than it ever has before, which sounds unambiguously good until you understand what it means for the people responsible for actually deploying those fixes. Over 40% of the fixes in this release originated from AI-assisted discovery, whether through Microsoft's own AI-powered red teams, automated fuzzing engines, enhanced by machine learning, or Security Copilot's continuous analysis of production telemetry. One specific example illustrates how this works in practice. The http.sys bug was spotted because an anomaly detection model noticed an unusual pattern in kernel memory allocation during automated stress tests. A human reviewer looking at the same code might never have noticed the pattern. The AI did, because it was doing something no human reviewer can, analyzing millions of lines of legacy code simultaneously, looking for subtle correlations between memory allocation patterns and potential exploitation vectors. This is genuinely impressive security engineering, and it has real measurable benefits for every Windows user who installs the patches. The June 2026 update touches nearly every corner of the Microsoft ecosystem, from Windows and Office to Visual Studio Code, to Exchange Server, Azure Components, and developer tooling. At least 5 vulnerabilities were known to have been exploited in the wild before patches landed, including a 0-day remote code execution flaw in the Windows print spooler service and a critical flaw in Internet Information Services, HTTP. That print spooler vulnerability matters in particular because the print spooler service has been one of the most persistently exploited components in Windows for years. A recurring target for attackers who know that patching cycles in enterprise environments often lag weeks behind Microsoft's release schedule, leaving a predictable window of exposure. Finding and closing another print spooler vulnerability before attackers had more time to weaponize it is exactly the kind of result the AI-assisted discovery process is meant to produce. Also among these 0 days was CVE 2026-50507 in Windows BitLocker, arising from a protection mechanism failure in how BitLocker handles device encryption, which enables an attacker to access encrypted stored data with no need for credentials if they have physical access to the device. The physical access requirement limits who this is practically exploitable by a sophisticated attacker who can physically reach a device, not a remote attacker, scanning systems from across the internet, but the potential impact is significant. BitLocker is exactly the security control organizations rely on to protect sensitive data when laptops are lost or stolen, and a bypass that undermines it has real consequences in environments where endpoint encryption is a regulatory compliance requirement. Discovering this class of vulnerability through AI-assisted code review and patching it before it became widely known in the attacker community is a genuine security win, regardless of the operational pain the patch itself might cause. Here's where the user frustration enters the picture, and it's legitimate frustration that deserves honest treatment rather than dismissal. The same AI-assisted discovery process that found 200 vulnerabilities also produced a 200 fix update, and 200 fix updates are not small things. Windows 11 updates have grown dramatically over recent years. When Windows 11 first launched in 2021, cumulative updates measured in the hundreds of megabytes. By the 25H2 era, the most recent updates weigh in at approximately 5.1 gigabytes. That's not a rounding error in update size. It's a more than tenfold increase over a few years. And the June update arriving on top of that baseline means a significant chunk of bandwidth consumed on every managed device that needs to apply it. For enterprise IT teams managing hundreds or thousands of machines, the logistics of deploying a 5 gigabyte plus update across an entire fleet is not a trivial afternoon task. Part of the size increase is attributable to AI-related components. For Copilot Plus PCs with a neural processing unit, updates include several gigabytes of AI model data used for core features like semantic search. This is the dimension of AI involvement that has generated the most direct user complaint. Not the AI that found the vulnerabilities, but the AI features being bundled into Windows. Updates and shipped to machines that didn't ask for them. The distinction matters because these are actually different problems with different solutions, but they share the same surface-level symptom, a Windows update that's larger, more complex, and more capable of breaking things than updates used to be. When users and IT administrators see an update fail and look for a cause, AI bloat becomes a convenient and not entirely inaccurate shorthand for a set of real grievances, even if the specific mechanism isn't always what they think it is. The actual breakage in the June update cycle is real and documented. Microsoft confirmed that the May 2026 security update, KB5089549, was failing to install on some devices, resulting in error code 0x800F0922, and provided a registry-level workaround requiring users to modify a value that reduces the reserved padding Windows 11 uses inside the EFI partition during servicing. If that sentence sounds like something no ordinary Windows user should have to parse, that's because it is. The workaround involves opening an elevated command prompt, running a specific registry command, restarting, and then manually triggering the update again. This is not the kind of remediation process that inspires Confi. Hence, in a company that has spent years telling consumers their OS just works. And the pattern of it happening isn't new. Windows 11's April 2026 update KB5083769 triggered BitLocker chaos, and an earlier March update was breaking sign-in before a fix was issued. KB5's C19391 was pulled entirely after installation failures. At some point, a pattern of individual incidents stops looking like isolated bad luck and starts looking like a systematic problem with the testing and validation process that happens before updates reach users. Microsoft also confirmed that customers in network-restricted environments, ranging from fully air-gapped systems to strictly firewalled enterprise networks, encountered a separate class of update failures. Affected systems would display error code 00802 after installing January 2026 optional updates, and could subsequently become unable to install updates from March onward due to changes in download timeout requirements. This is a failure mode that almost exclusively affects precisely the class of environments where Windows security is most critical: regulated industries, government agencies, financial institutions. The organizations running the tightest network controls are exactly the ones who got locked out of updates because of changes to how the update system handles network timeouts. The irony is pointed. A security update cycle that's supposed to protect high security environments is being disrupted by changes that break update delivery in high security environments. The users blame AI code framing in the headline of this piece is worth examining with some precision because it conflates two separate things that are genuinely worth separating. When users and tech commentators express frustration about AI causing Windows update problems, they generally pointing at one of two distinct issues. The first is that AI features being built into Windows are making updates larger, more complex, and more likely to have unexpected interactions with system components. A legitimate concern about where Windows product development is going and whether the pace of AI feature addition is outrunning the testing infrastructure's ability to validate it safely. The second is that the AI-driven vulnerability discovery process is producing updates so large that they themselves become operationally disruptive to deploy. A genuine tension between finding more bugs and fixing them faster, which is good, and the practical reality that fixing 200 bugs at once creates a massive surface area for something to go wrong during the patching process itself. Both concerns are real. Neither one is the complete story. Microsoft has been revisiting Windows 11 following a series of botched and sometimes unscheduled updates and disgruntlement from users over poor performance and unhelpful AI features. That revisiting is an acknowledgement that the current trajectory is causing real problems, not just theoretical ones. The question being debated inside and outside Microsoft is whether the right response is to slow down AI feature integration while testing infrastructure catches up, to invest more heavily in testing infrastructure to match the pace of development, to change the update delivery model to make large updates less operationally disruptive, or some combination of all three. There are reasonable arguments for each approach, and the right answer probably looks different for consumer users, small businesses, and large enterprise environments. The median time between a vulnerability disclosure and active exploitation by attackers has shortened dramatically, and organizations now face pressure to complete patching within 3 days of a critical vulnerability disclosure for the most severe flaws. This is the hard reality on the other side of the equation from deployment pain. Every day, a critical remote code execution vulnerability goes unpatched on a public-facing system is a day that system is exposed to attackers who are increasingly using their own AI tools to accelerate exploitation. The 5 vulnerabilities in June's release that were already being exploited in the wild before the patches dropped are a reminder that the attackers don't wait for IT teams to finish compatibility testing. They exploit the window between disclosure and deployment, and that window has been getting shorter. The pressure to deploy faster isn't arbitrary bureaucratic urgency. It reflects a genuine change in the threat landscape. Microsoft's internal M-AI and related code reviewing systems can audit mountains of legacy code, spot subtle coding errors, and identify potential exploitation vectors. Task, as that previously required months-long manual code audits by elite security researchers. The security research community has generally reacted to this development with cautious optimism rather than alarm. Finding vulnerabilities in your own code before attackers find them has always been better than the alternative. AI is simply making that process faster and more comprehensive. The concern isn't that Microsoft is finding and fixing bugs. It's that the organizational and operational infrastructure for handling security updates at this new scale hasn't fully caught up with the technology that's generating the volume. Microsoft has already begun experimenting with out-of-band updates and an accelerated cadence for Azure services, and Windows 12, expected later this year, is expected to include an adaptive security feature that can apply virtual patches via hypervisor introspection, effectively neutralizing some kernel vulnerabilities without a reboot. That second detail, patches that don't require a reboot, would be a significant quality of life improvement for both enterprise, administrators, and consumers, addressing one of the most practically disruptive aspects of the current patching experience. Whether it arrives in time to change the conversation around Windows 12's launch is an open question. For users and IT administrators dealing with the current situation right now, the practical guidance is fairly consistent across sources. The June 2026 updates contain real, serious security fixes for actively exploited vulnerabilities, and the risk of not applying them is meaningfully higher than the risk of encountering installation failures. For most systems, the updates install without incident. For systems that hit the 0x800F0992 error, the registry workaround Microsoft published is the current resolution path. For network failures, so the specific mitigation varies, and checking Microsoft's support documentation for the relevant knowledge base article is the appropriate next step, given how rapidly the situation has been evolving. The larger story here isn't really about whether AI broke Windows, because the framing slightly misidentifies both the problem and the cause. AI didn't break Windows. A combination of an unprecedented vulnerability, discovery volume, an update delivery system under strain from increased complexity, and specific bugs in how updates interact with EFI partitions and network timeout logic, produced a rough few months of Windows updates. AI was instrumental in finding the vulnerabilities being fixed. AI-related features are contributing to update size in ways that create operational challenges. Both of those things are simultaneously true and aren't really in tension with each other once you separate them. What's actually broken is the gap between how fast Microsoft can find and fix vulnerabilities and how smoothly the infrastructure that delivers those fixes to several 100 million Windows machining can absorb that volume without causing new problems in the process of solving old ones. Closing that gap is the real engineering challenge, and the next several months of Windows updates will be the clearest available evidence of whether Microsoft is making progress on it. Let's get specific about why the vulnerability numbers are so much higher than they used to be, because AI found more bugs is accurate but undersells the mechanism. Traditional software security auditing relies on human researchers who are skilled, expensive, and limited by the number of hours in a day. They typically focus their attention on the most obvious attack surfaces, the parts of the code that handle network input, authentication, memory allocation, or other classic vulnerability categories. Legacy, code that has been sitting in a code base for a decade or more, quietly doing something unglamorous like handling a specific file format or managing a particular system service, often doesn't get the same level of scrutiny because there are only so many hours and only so many researchers. AI-powered code review doesn't have this problem. A system like M- can work through a code base at a rate that no human team matches, applying consistent analysis to every function, every file, every path through the code, regardless of how obscure or unglamorous the component is. It can hold the entire context of a complex function in scope simultaneously, recognizing patterns that indicate potential vulnerabilities, even in code paths that might be exercised only in unusual circumstances.
The http.ss finding is a good example, an unusual pattern in kernel memory allocation during automated stress tests, noticed because an anomaly detection model was watching for exactly that kind of subtle irregularity. A human reviewer looking at the same code during a manual audit without the benefit of running millions of stress test cases simultaneously would likely have missed it. These are real bugs in production Windows code that would otherwise have been found by attackers rather than by Microsoft. The counterargument, and it's a fair one, is that finding all these bugs simultaneously and shipping them all in a single update cycle may itself be creating unnecessary risk. The argument runs like this. Each individual patch is tested in isolation, the 200 patches interacting with each other, with the firmware on thousands of different hardware configurations, with third-party software, and with various enterprise network environments, is an exponentially more complex testing surface than any individual patch. The update failures that have been documented aren't happening because individual patches are wrong. They're happening because the combination of changes is triggering edge cases that didn't appear in testing. A case could be made for shipping the AI-discovered vulnerabilities in smaller, more frequent batches rather than accumulating them into a single massive monthly release, accepting slightly higher operational frequency in exchange for lower deployment risk per event. Microsoft's own direction suggests they're thinking along similar lines. The experimentation with out-of-band updates, patches chipped outside the normal monthly cycle for critical issues that can't wait, and the accelerated cadence for Azure services. Both point toward a model where not everything waits for the second Tuesday of the month. Windows 12's rumored adaptive security feature, which would apply virtual patches through the hypervisor without requiring the traditional patch restart validate cycle, is the more ambitious version of this idea. If the hypervisor can intercept and neutralize exploits for a known vulnerability while the full patch is being tested and deployed, the relationship between vulnerability exists and system is actively exploitable. Changes in ways that could fundamentally reduce the urgency pressure around immediate patch deployment. That's still in the future, but it represents the direction the problem solving is heading. For enterprise IT teams specifically, the June 2026 release has accelerated a conversation that was already happening. The traditional Patch Tuesday cadence of wait for the update, test it, deploy it over several weeks simply doesn't work anymore in its original form. The US government's requirement that certain agencies patch within 3 days of a critical vulnerability disclosure is the most aggressive version of a standard that private organizations are also being pushed toward by their insurance carriers, by their compliance frameworks, and by the basic risk calculus of a threat environment where time to exploit has compressed from weeks to hours. The answer isn't don't test before deploying. It's build testing infrastructure that can validate critical patches at speed rather than treating patch validation as a weeks-long manual process. Automated patch testing, ring-based deployment to canary groups before broad rollout, and AI-assisted compatibility checking are all tools being adopted faster in the wake of months like this one. For home users and small businesses who don't have enterprise patch management infrastructure, the situation is different in an important way. You're not in a position to delay patches for weeks of compatibility testing, and you shouldn't be. The default Windows Update behavior of installing updates automatically is the right default for the overwhelming majority of consumer and small business. Windows machines. The risk of not patching a system with 6 actively exploited 0 days far exceeds the risk of hitting an installation failure on the update that fixes them, and if you do hit an installation failure, Microsoft has published workarounds for the specific issues documented in this release. Error 0aux800F Stein22 on the May update has a specific published registry fix. Network-restricted environments have documented support articles. These are real problems with real solutions, not an update cycle that's fundamentally broken for everyone. The BitLocker situation in this update deserves particular attention for anyone using a Windows laptop for business purposes. CVE 2026-50507 is a bypass vulnerability in BitLocker, the full disk encryption that's supposed to protect your data if your laptop gets lost or stolen. The specific exploitation requirement is physical access to the device, which means this isn't a remote attack vector, but physical access is exactly the scenario BitLocker exists to protect against. A stolen laptop, a device left unattended at a conference, a machine seized at a border crossing. These are the scenarios where BitLocker's guarantee matters. And this vulnerability undermines that guarantee on unpatched systems. Patching this one is especially important for anyone whose threat model includes physical device access, which is essentially every business traveler and most knowledge workers. The practical upshot across all of this is that the June 2026 Windows Update represents a real, significant security improvement for users who install it, combined with a real, documented set of deployment challenges for specific hardware and network configurations that Microsoft has largely addressed with published workarounds. The AI angle cuts both ways. The same AI tools that made the record-breaking vulnerability discovery possible are also contributing to the update complexity that's making deployment harder. Microsoft's challenge going forward is building update delivery infrastructure that can handle AI-scale vulnerability discovery without the operational disruption that accompanied this particular release. The users blaming AI for Windows breaking aren't wrong that AI is part of the story. They're just not completely right about which part of the story it is. The next several months will tell us whether this is a painful inflection point on the way to a better security model, or the beginning of a sustained period of update-related turbulence that forces a more fundamental rethinking of how Windows delivers security fixes at scale. Watch whether the July and August Patch Tuesday releases return to more normal volumes as the AI tools work through the accumulated backlog of legacy code issues, or whether 200-plus fix updates become the new baseline. Watch whether the deployment failure rates documented for recent updates improve as Microsoft applies lessons from the May and June incidents, or whether new failure modes surface. And watch whether the Windows 12 update delivery changes, when they arrive, actually reduce the operational burden on IT teams in the way they're being positioned to do. That's the actual story underneath this month's record-breaking numbers, and it's one that's still being written.